have some more applications of lesson 10.5. I got a little cut off on the last video. So I want to show you some problems. The first thing I want to do with this is on page 785. I want to do number 22. So take a second, 21, take a second, look at that problem in your book. There's a really nice picture. And the question is asking you to find the area. So here's a great formula. So the area of a triangle, all right? So if you had Mrs. Murphy, what you're gonna need to, or any of your geometry teachers last year, what you're gonna need to do is plot those points, find the altitude, area is equal to 1/2 base times height. But with our matrices, this is fabulous. We know the area of a triangle is equal to plus or minus 1/2 the determinant, okay? That's it, that's all we're gonna do. So in number 21, we have the ordered pairs 0, 0, 3, 1, and 1, 5. Okay, so those are the three. So I'm gonna make a matrix out of those three. 0, 0, 3, 1, 1, 5. Okay, look at that. Oh, wait a minute. That's not a square matrix. And how am I gonna find the determinant of if it's not a square matrix? So what I'm gonna do is I'm gonna put placeholders here. I'm gonna put some ones here. Now ones are not gonna change the value of my determinant. They're just gonna be placeholders. So what we're gonna have is we're gonna find the area is equal to plus or minus 1/2. Now, why do I say plus or minus? Because our determinant might end up being negative, and that's a problem. We cannot have a negative determinant. So what you want to do is, if it's a positive, keep it positive. If it's negative, keep it negative, or change it to positive, okay? So we're going to take this and we're going to figure out that it's going to be, oh, we need the determinant, right? So these should be like determinant marks, not matricing marks. Cancel those out. Doing it all in one take, folks. Doing it all in one take. All right. So we're going to take these numbers, 0, 3, 1, 0, 1, 5, 1, 1, 1. I'm going to basket weave. Here we go. You coming along with me? Ready to basket weave? Okay. So I've got my numbers in place. I'm going to go ahead and I'm going to just multiply straight on down as I go. All right. Keeping those numbers nice and neat. So let's see, my determinant is going to be equal to, let's see, 0 times 1 times 1, 0. Love it. 0 times 1 times 1, 0. 1 times 3 times 5, 15. Fabulous. Okay, minus. Now we're going to go the other direction. Multiply as I go straight out and up. I see those zeros. I'm excited. 1 times 1 times 1, 1. 5 times 1 times 0, 0. 1 times 3 times 0, 0. Okay, so then I've got 15. My determinant is 15. Making sure you can still see this on my paper. 15 minus 1, which is 14. All right, I'm ready to come right back up here. So I have plus or minus 1/2 of 14. So let's see, half of 14, that's 7. So it's 7 square units. That's it. Isn't that wonderful? Great problem. The second one I want to share with you this afternoon or this morning or whenever you're watching my handy dandy video is we want to find the equation of a line that goes through the points 2, 4, and -1, 3. Okay. Well, we can use a matrix for that too. I know. Normally, you would have to plot those points, find the equation, find the slope, find the y-intercept, go ahead, put that in. That would be a lot more work. We don't even need to do that for this. Our matrices are going to help us out. So what we're going to do is take it, make this a matrix, 2, 4, -1, 3. Okay, easy enough. But in order for us to make this a matrix, we need to add an x and a y because every equation has an x and a y. Well, this is the column for x's, and this is the column for y's. And that's not a square matrix, is it? So I'm going to go ahead and I'm going to add some ones as placeholders. Ones are great placeholders. Now, the rule here is that the determinant here is going to be equal to, of this new matrix, is going to be equal to 0. So I'm going to have the determinant with my bars. They're not absolute value bars. They are I don't know, determinant bars. We need to do our basket weaving. I feel like I'm doing a lot of it. 2, -1, y, 4, 3, 1, 1, 1. If you did not like the basket weaving method, you wanted to use the cofactor method, that's totally fine. Completely up to you. All right, so we're gonna go ahead and multiply. Ooh, you can see what's happening, can't you? Look at that. Okay, so here I've got, let's see, x times 4 times 1, which is 4x, plus y times 1 times -1, which is going to be -y, plus 1 times 2 times 3, which is 6, right? Minus, then we're going to go the opposite direction, right up here. There it is. -1 times 4 times 1, which is -4. 3 times 1 times x, which is 3x. And then 1 times 2 times y, which is 2y. And I'm going to set that equal to 0. Okay. Well, this looks a little awkward, doesn't it? Let's clean it up. 4x minus y plus 6 plus 4. Looking a lot better, isn't it? 3x minus 2y equals 0. I'm almost done, and I'm almost at the end of the paper. So let's see. We've got 4x minus 3x. That's going to be x minus y minus 2y, which was going to be -3y. And then I've got 6 and I've got 4, so that's plus 10 is equal to 0. There, my friends, is the equation of a line using the determinant of a matrix. Now, I showed you two things today. I showed you the equation of the line. You're going to use the placeholders of 1's and x and y's because every equation has an x and y in it for a line. And I showed you over here that the area of a triangle is equal to 1/2, plus or minus, of course, 1/2 the determinant.